So, good day. We are Group 1. I am Gracie Cortez, and my group mates are Aaron DEGUZMAN, Alden Evangelista, Don Roque, and John Valenton. So, we are here to present about the Experiment 8, fiber optic demonstration, attenuation measurement, and applications. So, first is what is fiber optics? So light was used as a communication tool in the earliest of times. It was discovered by John Tidal in an experiment that gave birth to a revolution the the use of lights in the communication system of humans. It became the creation of the fiber optics. So optic fiber is a transparent material that can transmit light. So for the history of fiber optics started during the 18th century. In this slide, you will be able to see the timeline of the fiber optics history. So, so for the 18th century, light possesses a great contribution to the telecommunication system in the early ages. It was not until the late 18th century that it was discovered that light can be transformed and can be applied into communications by complex light-based system which is called the semaphore system. It is a concept whereas towers were built with pivots on top of it enables the encoding of messages in accordance to the mechanical position of the pivot and the lights that were emitted. So the concept of optic fiber and its application started in the 1880 when an optical telephone was patented, a device created by Alexander Graham Bell, which is as he called as the photophone. The device could encode the sound signals which is transmitted into a beam of light which has a varied intensity that represent tones. So since the created requires a visible line of sight, it created a complication in the electrical counterparts. Research was conducted by then in the beginning of the 20th century. Quart- Quartz rods was discovered to carry light and were used to microscope illumination. In this duration, different people tried to use the phenomenon. So during the 1920, John Logie Bart and Clarence W. Hansel patented the idea of using arrays of pipes to transmit images for television or facsimile systems. And then in 1930, it is the year that Heinrich Lamb reported image transmission through a bundle of optic fibers. So in the following year, um, Owen, Illinois devises a method to mass-produce glass fibers for fiberglass. However, curved light sails in 1939 discovered illuminated tongue depressors and dental illuminators made of lucite. But during the 1949, Holger Moller Hansen and Abraham C.S. Van Hill investigated image transmission through bundles of parallel glass fibers. Then, after the first half of the century, innovation in the fiber optics occurred. Then in the year 1954, Van Hill, Nor Hopkins and Company created bundles of fiber that could carry the light even further. And in this innovation consists of cladding layer surrounding the material with lower than air refractive index which is responsible for protecting light beam from noise and reduces crosstalk between fibers. And then after that, during the 1964, an engineer named Charles Cow conducted a research and was convinced that attenuation is caused by impurities and it is theoretically made possible that this attenuation can be reduced. It is shown that in the first years of evolution of fiber optics, the concept of light was used mainly to transfer information. But as the years passed by, evolution occurred and innovation was made by certain individuals through their own discoveries. So, for the next slide, This is the discussion about the optical transmission diagram. So, from the given figure, it is the optical transmission block diagram. The electrical signal is given as the input. This input signal goes through the driver circuit and a light source. The light source is the one that translates the electrical signals into light particles or wave. The light the light source usually utilizes an LED or laser. The driver circuit and light source is the transmitter part of the circuit. The transmitter part of the circuit is connected to the optical fiber, which is the cable. Sometimes an optical splicer is used to lengthen the cable of the optical fiber. Next is the signal that is being propagated through the fiber goes through an optical coupler. The optical coupler may be utilized to connect the signal to multiple receivers, which is our users. Then the signal goes through the regenerator circuit, which is composed of the optical receiver, electronic circuits, and optical transmitter. The regenerator is used for long distances of transmission since the signal gets weak as the signal travels through the long cables. Afterwards, another optical splice may be used in order to lengthen the cable. Again, lastly, the cable is connected to an optical amplifier to get a hold of a better amplitude of the signal. It is connected to the receiver circuit, which is composed of a photodetector, an amplifier, and a signal restorer. The photodetector is the circuit that receives and detects the light signal, then coming across to another amplifier to make sure that the signal is properly received, and then a signal restorer, which are either a low pass filter or a high pass filter. Then it is back into an electrical signal for the output. So next is the type of fiber optics.
So with this part, types of fiber optics, there are two categories in the fiber optics, which are the number of modes and the refractive index. There are two types of classifications under the number of modes, namely the single mode uh, fibers and the multimode fiber. So first one is the single mode fiber. So what is a single mode fiber? It has only one mode that transmits through them. Single mode fibers' diameter of the core is substantially small and has no dispersion effect. It is also widely used for long distance communication, but it is expensive and difficult to produce. The next one is the multimode fibers. So this is more than one of the multimode fibers to transmit via the optical fiber. So the wider the core radius, the simpler it is to launch optical power to the fiber and perform end-to-end connections. So two forms exist under the refractive index, namely the step index optical fiber and the graded index optical fiber. So what is step index fiber? So this step index fiber constant refractive index of a phase index fiber was N2. So at its center, you can see here, the refractive index decreases expectedly from N2 to N1 and remains constant in the cladding section. So the next one is the grade index fibers. So in this part, the refractive index of the core N1 gradually decreases the graded index fiber. So beginning from the center of the core to the center of the optical fiber. Next slide, please. So here's the propagation of the signals in a fiber. You can see here, the first one is numerical aperture. So a numerical aperture, that is a number lower than 1 that determines the optical fiber's light collecting power. For this cable type, the standard numerical aperture number is 0.275 to 0.29. It can be written mathematically as a symbol of the angle of acceptance, as seen in the figure in numerical aperture. So the next one is the total internal reflection. So the total internal reflection follows the principles of reflection. So the incident angle must be greater than the critical angle. And of course, lastly, cone of acceptance. So the acceptance cone typically indicates the angle wherein the light will reach the wire, resulting in complete internal reflection. So in the formula below is the acceptance angle. You can see here the arc sine times square root of n squared 1 and 2 squared and all over n naught. Next slide. So here are the advantages and disadvantages of fiber optics. So first, the advantages of fiber optics. So first one is it has more bandwidth, lesser degradation, and reliable in long-range transmission, and of course, it is durable. And one of the disadvantages of it is that it can only be used on the ground. Another thing is that it is very fragile and it has a disadvantage also with the proportion with uh, the fiber optics itself. Next, please. So that's our report for our experiment 8, and that concludes our laboratory experiment. Thank you.